Dear students, I welcome you in this lecture on the topic population and sampling. In this lecture, we are going to see simple random sampling without replacement and stratified sampling. Let us see simple random sampling without replacement. Its standard abbreviation is SRSWOR. SRSWR, and the long form is simple random sampling. Simple random sampling without replacement. In simple random sampling without replacement, that is SRSWOR, the repetition of elements is not allowed. The repetition of elements is not allowed. It is not allowed. In SRSWR, we have seen that repetition is allowed. So, in SRSWR, repetition is allowed. What is SRSWR? It is simple random sampling with replacement. Whereas in SRSWR, repetition is not allowed. Repetition is not allowed. This is the main difference between SRSWR and SRSWR. We are studying SRSWR, simple random sampling without replacement. An element is selected and it is kept aside after recording it. So, from the population, an element is selected. From the population, element is selected, it is recorded, and it is kept aside. It is not replaced back. It is not replaced back. In case of SRSWR, we have seen that it is replaced back into the population, but in SRSWR, it is not replaced back. It is not replaced back. Okay, so this is the main difference. Another element is selected, again it is recorded, and again it is kept aside. So continuing in this fashion, elements get selected and they are kept aside. So the precise procedure in which the process of obtaining simple random sample by using SRSWR method, that is simple random sampling without replacement method, can be described as: the first step is to enumerate units in the population from 1 to n. Enumerate means give numbering, give numbers to them. So it is numbering elements in the population, elements in population. N is size of population. Note that here n is size of population. Size of population. A second step is a random number in between 1 to n is selected. Choose the sampling unit. Choose the sampling unit whose serial number corresponds to the number selected. Another random number in between 1 to n is selected. If the number has not been selected previously, then the sampling unit whose serial number corresponds to the random number selected is included in the population. If it was selected earlier, then it is rejected because repetition is not allowed. For example, consider the case where we have 1 to 100 elements in the population. Suppose element whose serial number is 6 gets selected. In the second step, if 6 appears again, then it is not selected, it is rejected. But in SRSWR, the same was accepted because repetition was allowed. Okay. Then this procedure is continued till the sample of required size is obtained. This procedure is repeated till the sample of required size is obtained. Such a process can be implemented through programming and using the discrete uniform distribution. Any number between 1 and n can be generated from this distribution and corresponding unit can be selected into the sample by associating an index with each sampling unit. There are many statistical software like R, SAS which have inbuilt functions for drawing a sample using SRSWR. So this was about simple random sampling without replacement. Now let us see another method of simple random sampling. This method is stultified random sampling. So we'll try to understand the basic idea in this method of sampling. This method of sampling is used when the population is heterogeneous, means not homogeneous or not of one kind. It is not of one kind. So there will be, if we consider this as a population, it can be divided in of different types. These are different parts, sectors or homogeneous. So this can be divided in different parts. Each such a group, this is population, and each such a group is called stulta. So it is called stulta. A random sample from each stultum is taken in a number proportional to the stultum size when compared to the population. For example, if this has, say, if this part has bigger size, then more elements will be selected. So elements are selected so if stultum has more number of elements, then more number of elements will get selected from this stultum. From each stultum, corresponding elements get selected. Say, if this stultum has less number of elements, then less number of elements will get selected from this. If we have another stultum with some elements from the population, then proportionate number of elements will get selected from in the population. In this way, a sample will be obtained from stultified random sampling. The main advantage of using stratified random sampling is the way it captures the key characteristics of the population in the sample. Similar to a weighted average, this method of sampling produces characteristics in the sample that are proportional to the overall population. Stratified sampling works well for populations with a variety of attributes. It is not useful or it is ineffective for subgroups of the when the subgroups of population cannot be formed. So if subgroups of population cannot be formed, then this is going to be ineffective method. This was the concept of stratified random sampling. Thank you.